Okay, it's been a little while, I think, quite a few weeks actually, since I put anything out there. Um, it was probably going to be a little while longer as well, but I got bombarded with information about World Quantum Day from all of the information streams that I'm in, so I figured I had to do something for it. If everybody else is, all the other companies and stuff are making a big deal out of this. I'd never heard of, World Quantum Day before recently, and so I don't know. I don't really know what the deal is or why it's a thing, but it's a thing. So I'll embrace it. And you can see I just opened up some. I don't know. I Googled World Quantum Day, and this was the first thing that came up. So I don't know if this is a real one or not, but you can see that says April 14th, which is today. Um, that at least the time of recording. I can't speak to the time of viewing. Um, so yeah, today this is going to be brief. I guess this is sort of I guess kind of exciting foray into something new, and we're going to be running something on real hardware today. I think for the first time ever that I've done on this channel. I'm 99% sure this is the first ever hardware run on any service. And so I got some free credits through. I don't even remember what it was. I got them a while ago. They were giving them out to everyone. It's not like I was special for Microsoft's Azure or Azure. I don't know how you say it. Their quantum computing interface. So they don't have their own quantum computer. I think they're trying to build one, but they did topological qubits and then they like falsified data and that got retracted. That was a whole thing. But um, they do, similar to AWS, have an interface where you can connect to different hardware providers. And so, um, yeah, I guess I don't want to talk too much about it. I'll show rather than tell about it. But that's just explaining why. Not that the money matters. I don't know. I can find it maybe, and if I do, I'll link it below. Um, oh, I found it just now. Actually, you can see here that first time users, so everyone get $500 of credits. So that's what I'm doing. I mean, it doesn't really matter. The runs I'm going to show to cost like 30 cents or something, not even. Well, I don't know exactly, but not very much money at all. Um, but there is that. So I didn't actually pay for any of this. You wouldn't have to pay for this if you wanted to do this either. Um, and so, yeah, I guess I shouldn't dilly-dally around the point for any longer and just get into it. So if I go over, you will notice that my screen is sort of clipped, and that's simply because I don't I don't really use cloud computing resources that much, so I don't know what's important to show or not show. So I don't want to like leak the cloud like name or the resource name or something if that's like something I'm supposed to keep secret or whatever. So I'm just cropping it to the relevant information. You'll see that's also why the service is highlighted in red, is because um, there was a defined variable, but then I deleted it so I wouldn't accidentally screen share that. Uh, so you can see that this prints out all of our available um, all of our available services. I don't really know. I've looked them up, but I don't really get what these. This is the simulator. I don't get what these are. Um, I think these are the real ones, but rather than figure it out, because one, the IonQ hardware had about a way lower estimated queue time. It gives you like an estimated queue time when you look at your providers, and it had a queue time of like 3 hours, whereas Honeywell had a queue time of like 17 hours. So, you know, just support not defense contractors when you can is something that I'll do. So, I'm just going with the IonQ QPU. And so this is the 11 qubit system that was mentioned in their NatCom paper. I don't know if it's like a clone or a different actual physical instantiation, but it's 11 qubits. So we're going to be using all of them. And we're doing an extremely simple circuit here, as you can see. We're just going to be generating random samples. So I haven't really motivated, this is kind of rambling, I haven't really motivated what we're doing. We're going to be doing my first foray into not only running on real hardware, well, I have run on real hardware, but first time on this channel, but also the first sort of artistic endeavor from the quantum realm. And so you'll see where this is going. So first we need to generate, basically we use quantum randomness to generate samples that we're then going to work with. So we, I'm using Cirq. You can use other things. I don't know. I don't really know a lot about Azure or interfacing with hardware, so I'm not going to speak onto whether what I'm doing is good or not. But this is just basic Cirq creation. I copied this stuff from the tutorial, so I don't know if it's good or not, but we're specifying we want to run on their quantum processor unit. We're choosing 57 repetitions because I need 57 data points for this art. And yeah, they only have one QPU. That's their 11 qubit service. So we get our job ID. I don't know if I don't know if that's a good thing to share or not. I don't think it matters. Then we get the results. This took, you can see, 31 minutes. It did not take 3 hours to get through Q. I don't know how their queuing system works. Maybe because my job was so simple, they realized that it would not take long. This sum is not important. That was for a previous challenge I was encountering. Then I have a method that converts a binary list to a decimal value. And then I have this function here, which I copied from the Cirq code, but there was some error with the Cirq import. That's why it's the way that it is. But here we have this conversion from the basically converting the result data type from the IonQ backend to the like to a list of actual measurements that we got. So I didn't write this code. This, if you go to the Cirq IonQ like homepage on Google Quantum AI's website and click on view source, you'll be able to get this exact code. I mean, I slightly modified it, but basically this exact code. And the reason I'm using this, there is a convert to Cirq result, but there are some problems. You can see the probability isn't exactly 1 due to how the computer is representing floating point numbers. And this was throwing it off when it was using these weights to generate a result. And so I had to renormalize them because they are right. It's just floating points. So that's not exceedingly relevant. This just converts it from the IonQ result to the measurements that we care about. Then we normalize all of the measurements to be between 0 and 1 because we have 11 qubits here. And so these are our results. And then we use these results. So these are from the real quantum hardware. And then we get them to plot this little Q here. So I did this by hand, probably not the most efficient way of figuring out which values were needed. So everything is white or ones. 1 indicates whiteness in the RGB scheme. And then this Q here, each one of these RGB values is dictated by the random measurements from the quantum computer. And so, you know, this is a sort of short and sweet video, but this is all it really is. This is my sort of contribution to World Quantum Day, is a little piece of art. I don't know if I can call it art, but I guess that's a question for the aesthetic philosophers. But so there you go. This is, if you want to use it, you can get $500 free credits, or you could spend the like 30 cents or however much this costs to run. It's literally 57 shots, so I can't remember how much it is, but it's like less than a cent per shot or something. So it's not a lot. So this is, yeah, that's it. There's not a lot to say because it's not a lot of originality here, and I don't have a lot of expertise on interfacing with Azure or IonQ, so I'm just going to leave it at that. But here's the contribution to World Quantum Day right here. The truly quantum Q, I'll call it that. Truly, or just maybe quantum Q, that's better. The quantum Q